Hello, everybody. Oh, that's very loud. I hope you've all had a really good break. I know that I sure did. I was only a week, but hopefully you're excited to be back and getting ahead with this content. We've got some really cool stuff coming up and just quickly working out how to put this on me. Okay, so thanks for the introduction, Mary Lou. We're going to be talking about a recap on model training, which we looked at before the break. And we're also going to be going into a little bit more details. And we're also going to be talking about fine tuning today. But one of the things that I think is going to be really cool for you guys is we're going to actually be playing with the real GPT-2 model. So we're going to be doing this in a lab this Friday. In preparation, let me just quickly get my computer. Okay, so in preparation for the lab, we have this interactive lab website. You don't have to visit this now, but I will show you how to access this shortly. You can just access the link there, but I also put it on our Canvas site. I'm just showing you this now because this is where this content comes from. But in this lecture, we will be going through all of these tasks. Now, why are we going through the content now and not in the lab? The reason why is there is a lot of content for the lab this week. And today, I want to really go through a lot of the content beforehand, as well as do a bit of a demonstration of the coding exercises, which means that when it comes to the lab, you can get straight into the group discussion questions and also playing around with some of this code. Now, I know I've said the code word quite a bit, just to really kind of like clarify things. In this course, you're not expected to know how to code. What this lab will be is we'll have snippets of code and all you have to do is run it and make small changes. But the changes will be very clear about what you should be changing and what you should not be changing. So hopefully this is going to be something that you're looking forward to, and I had a lot of fun making it, and I hope you have a lot of fun doing it. So to start off with, I just want to talk about the lesson outline. There are a lot of different tasks in the lab, and I want to kind of show you how all of them connect together. And so this is a flow chart that you're going to see over and over again today and also in the lab. So this flow chart just kind of breaks down the main steps that we're going to be talking about. So a model starts with training. This is pre-training, which you looked at in the last lecture. We're going to be building on this today as well by talking about fine-tuning. But this whole process of training is used to create a model. Once you have a model, so for example, this could be like ChatGPT, the model takes in a prompt, there's some inference process, which then results in an output. In considering this whole pipeline, we also want to consider the ethical considerations, and we'll also be doing a very quick introduction to that today. So the first task we're going to look at is going to be a recap of pre-training. That gives us our first outcome, which is to understand the key steps in LLM pre-training. And the main steps that we're going to focus on are tokenization, embedding, attention, next token prediction, loss calculation, and backpropagation. Now, lots of these steps should be familiar from the last lecture, but we are going to recap them today. The next task is we're going to be getting access to GPT-2. So I'm sure you guys have been using ChatGPT or you've been using Copilot, which also kind of uses, I believe there's like an arrangement where they're using the weights from GPT as well. GPT-2, which is a very old version, has been publicly released. And that's great for us in this course because it means that we can actually interact with it. And so task 2 is going to be about getting access to GPT-2 using some code, and I'll show you about that soon. In task 3, we're going to talk about the process of how the next token is actually chosen. Up to this point, we've pretty much told you that a model, predicts the next token, and that is true, but there actually is a lot more flexibility in the way that the next token is selected. And we'll be talking about that in task 3. And that relates us to outcome 2, understanding how training differs from inference, and that there are different sampling methods for selecting the next token. In task 4, we're going to look at fine-tuning, and that gives us outcome 3, understanding the difference between pre-training and fine-tuning. And finally, in task 5, you're going to consider the ethical considerations of this entire process. So there are lots of ethical considerations when you think about AI. The ones that we're going to focus on today and in the lab are mostly those that pertain to training. And that's outcome 4, to critically evaluate the ethical concerns related to LLM pre-training and fine-tuning. So let's get straight into it with task 1, looking at model pre-training. Now, as a recap of what pre-training is, this is the stage where the model learns about language, starting from random weights. The process it does to do this training is it reads heaps and heaps of text. So we're not talking about 1 or 2 books, 1 or 2 articles, we're talking about billions of them. So a lot of the time when people talk about training or pre-training, you might hear this concept, train on everything. Well, in actual fact, we're not training on everything. There are filtering steps. But the general idea is they're training on so much data. So this is a very large process and also a very expensive process. So pre-training, what actually is it? It's large-scale numerical optimizations using linear algebra, probability, and calculus. Today, we're not going to go into too much of the mathematical details of how pre-training occurs, though if you are interested, I encourage you, even go to your favorite LLM and ask it, what are the key mathematical steps? It is quite interesting, but today we're going to focus more on the main components, just to kind of get us an idea of how the scaffold works. So let's get into that then. How does this pipeline work? So in pre-training, we have all of these things called documents, and you can think of a document as just a collection of text that we're using for training, but you don't just have one document, you have heaps of documents. So to start off with, let's say we have our first document, which is here, just a sentence that says the cat sat on, okay? Clearly it's not a complete sentence yet, but let's just say that's what we have to start off with. The first process is what is called tokenization, and this is where we break the text into smaller pieces called tokens. Now, in this example, we have broken this sentence where each word is a token. It doesn't have to do that though. In actual fact, bigger words are usually split into subparts. So for example, the word photosynthesis maybe might take the part photo out because the word photo itself has meaning. So these words are not necessarily broken into word level tokens, but they are split up somehow. For today, we're just going to say that they're split into words just for this example. After we split them into tokens, the next step is embedding. Now, one of the things is we've been using LLMs a lot. I'm sure you use LLMs a lot in your day-to-day life. It's really important to realize the LLMs don't understand words, they understand numbers. And so underneath, what happens is these tokens get converted into a vector of numbers, which are called embeddings. Now, for those that have studied vectors before, vectors are kind of like, they're geographical geospatial. And essentially, words that have, or tokens that have similar vectors share similar meanings, okay? And so that's what's going on here. This is how a computer is trying to understand what these tokens represent. So we convert them into embeddings. The next process is called attention. And this is a method where attention mechanism looks at each token and it looks at every other token in the context to figure out which words are most relevant. So as an example of this, let's have a think about the word on. The word on might pay strong attention to the word cat, and the reason why is that the model would learn that tokens representing prepositions often rely on nearby nouns. So logically, the word on, it's linked to some sort of noun, which here is cat. And so attention would say it's likely that the word on is going to pay strong attention to the word cat because we're interested in what object is actually on here. After attention, we have next token prediction. So the model produces a probability for every possible next token. And during pre-training, what the model is trying to do is trying to get better and better at this prediction task. So at the very beginning, it would do quite poorly, but as we start repeating this process over and over again, it's starting to get better at making these probability predictions. After this is the loss calculation step. You can think about the loss calculation as measuring how wrong is the model to what we actually were expecting. So for example, the sentence here is the cat sat on. The actual word that we want is the. So the cat sat on the. The model also assigned a really high probability to the. So actually it did a really good job here. It predicted the actual word quite well. And so the loss is quite low. But when we're doing this loss, we're actually looking at a lot of the probability distribution, so not just the top word. After this, we have this step called back propagation. So if we think about it, as the model is going along, it's trying to predict these words, and then we do this loss calculation. We want to update these earlier steps, and that is what back propagation achieves. So you can think about back propagation as an error signal which flows backwards through each stage, adjusting the internal settings, which here are what we call the weights. Why do we do this? Well, we've realized that the model didn't perform as well as we would like it to, and so we're updating these weights, so the next prediction will be even better. Now, this whole example, and I've talked a bit about this as I've been going, the cat sat on, you can think about that as one document. In reality, we're repeating steps 1 to 6 heaps and heaps of times. Okay, so we're using lots and lots of different documents, enormous amounts of text, and with each pass, the model keeps doing this back propagation process, trying to get better and better at making predictions. So hopefully this was a bit of a recap on pre-training. In the lab, you're going to be doing a few different group discussion questions. So I'm not going to, these questions here on the slide are very simplified versions. Please look at the lab later on Friday to work out what you should be discussing here. We're going to be talking about questions around how do LLMs work, and particularly, what is the difference between pre-training and what happens at inference time when a human is interacting with an LLM directly. I want you to start thinking about how do these models learn versus how humans learn. I want you to consider whether these models truly understand language. And finally, how do these models predict the next word? Now, this last question, I actually realized in hindsight, we are probably going to spoil a bit in a second with some of these later exercises, but it's still useful to think about. So that is task 1. Now we're going to move on to task 2. Task 2 is kind of just like really the purpose of task 2 is just to get us to download the model. So there's not many slides here, but what we're going to be doing is on our own device, we're going to be loading a GPT-2 model. So in a second, I am going to switch screens to show you how to do this yourselves, but I want to really quickly show you the process. So we're going to be using Google Colab. Why are we using Google Colab? There are a few main reasons. The first reason is that we're going to be using some packages today in the programming language Python that can be a bit tricky to install. So I'm a tutor for another unit, actually the NLP unit, and we do something similar to this task. And even us tutors found it a bit difficult to install these packages because you can have conflicts. And so in Google Colab, they're already downloaded for us, so it's nice and easy. We can get straight into playing around with the code. The second reason why using Google Colab is ideal here is because Google offers a free GPU, which will speed up our calculations. So we're going to be using Google Colab. There's also a lab notebook that we're going to be using today. I'll show you how to download that very shortly. And finally, once you've set this up in Google Colab, we're just going to be running the code chunks, and it will be pretty clear in the Google Colab which ones we're going to run. So I'll show you how to do this now. I'm just going to switch screens, and I'm just going to go to Google very quick. So very quickly, on our Canvas page, I've put some links here for the workshop. There are 2 options here. Option 1 is the preferred one. If you click on this, it'll take you to the interactive lab page. Option 2, there is a printable version here, and you can also download the lab coding file as well. But I'm going to assume just for today that we're using the preferred option, which is this interactive site here. So really quickly, we'll go home. There's multiple different tasks, and this is the lab worksheet. So what will happen is you'll start task 1, you'll have a read this content, and you'll have a go at these group discussion questions. Then when the tutor directs you to, you'll move on to task 2, and this is where we're going to be loading a GPT-2 model. Now, if we scroll down, there is this button here to download the lab notebook. I'm going to click on that very quickly, and hopefully that works. It did. Always worry it won't work live, which would be very awkward, but it did, which is good. There's also a video here setting up your file in Google Colab. I am going to show you this live now as well, though. So feel free to watch that video on your own time. But if you're here in the lecture or you're watching this recording, we are going to do it now. So really quickly, I'm going to change tabs and I'm going to go to a Google Colab tab. So really, you just want to go to Google and search up Google Colab, and this will be the landing page. It may ask you to log in if you haven't already. You do need a Google account to be able to use Google Colab. If you don't have a Google account, you're welcome to make one, but also feel free to look on with the person at your table. So when you come to this page, automatically this will open up asking you to open your notebook. So you want to go to this one here, upload, and you want to find the file that you just downloaded and drag it in. So here's the lab file, model training and fine tuning. I can drag that into here and that will upload very quickly. Maybe not too quickly, but it does work. Okay. And this is the lab that we're going to be talking about and you'll be doing on Friday. So a few things I want you to note really quickly. When we're here, we have to choose a runtime. And so a runtime, you can kind of think about this as the computer that's working in the background that's actually running the code that you press to run. If this is a bit confusing, don't worry, just follow the steps that I'm doing now. So you want to come to the side here and press this down arrow and then press change runtime type. You can see that by default, my one is choosing GPU, but that's because I've used Google Colab a few times. And so it just knows that I want to use GPU. Most of you will have this CPU option selected. You actually want to change it to this one here, T4 GPU. This should, in theory, make the code faster to run. So once you've selected this, also making sure that we have Python 3, which should be there by default, press save. Once this is saved, you just want to press connect. Okay, and it will connect very quickly. So whilst this is connecting, let me quickly tell you a bit about this file. This is called a Jupyter Python file. The reason why I really like this is it allows us to write text. So this is just normal English text, but to also have coding chunks in between. This is really nice for a lab environment because it means that I can write some text to kind of guide you, but then also give you opportunities to run the code yourself. So the task we're doing now is task 2. There's some information here. There's a chunk here. You should not need to run this. These packages should already be available for you in Google Colab. So instead, we're going to run this cell here. A cell just refers to the chunk which code is contained in. So to find a cell, if you just hover over it, it has a play button. All I want you to do is just press this play button. What we're doing is we're running this code here. You don't have to look into this code, but this code, what it's doing is it's just loading the GPT-2 model so that we can use it soon. This code actually will take a few moments to run because we are essentially going online, getting the GPT-2 model and downloading it. And the GPT-2 model, it's not necessarily small, okay? So it does take a bit of time to run. You can see though, we've got some messages here loading, and I think we're actually almost done. Yeah, here we go. So I know some of these messages look a bit scary. You see some warnings. It's actually all good. Once you've run this and it says generator function ready and GPT-2 loaded successfully, that means we're good to go. Really quickly, how can we check that this also worked? We have another chunk here where we start with a prompt, and here this is called a string, and a string is just essentially a sentence. And so we say here, once upon a time, and what this generate text function is doing is it's taking the prompt and it's passing it to the GPT-2 model. And so let's see what happens when I run this. When I run this, it will say, once upon a time, the world was a place of great beauty and great danger. Okay, the world was a place of great danger. So you can see it's going on a bit of a rant, but this is us actually interfacing with the GPT-2 model. And I think this is so cool. This is a model that we're using locally now. So we actually have this. I mean, it's still technically in the cloud, but hypothetically, you could do this on your computer, and now you have access to a local large language model that runs entirely on your computer. So anyway, that was task 2. Very straightforward, just downloading the model, because tasks 3 and 4 are we going to be interacting with this model. So I'm just going to flick back now to the slides. Let's have a look at task 3. I'm just going to move my face up here. Oh, okay. So just a reminder, in task 3, this is the outcome, understanding how training differs from inference and that there are different sampling methods for selecting the next token. So what do I even mean by this? Well, so far, we've told you that what these models do is they find the probabilities of the next token. And so a question kind of arises. We've got all of these different tokens here and the probability attached to them. So for example, the cat sat on, the model is saying, I think there's an 80% chance that the next word is on. I think there's a 12% chance that the next word is A. The question is, how do we actually pick this next word? You may think maybe we should just take the highest probability, but actually it turns out that this might not be the best option. So what we're going to be talking about is what sampling method to use. In other words, the sampling method is how do we choose our next token from these probabilities? And depending on what sampling method we use, we will select a different token. So what comes after is the token this sampling method chooses or selects. So here on this slide, I've got a bit of an example. This is one sampling method that exists. It is called top P. How top P works is we start by sorting the possible next tokens by probability. So here is actually a slide, and I was interacting with Gemini when I was making these slides, and it actually just went ahead and made this really cool visualization for me. And it's actually interactive. So I think this is really cool in itself. So in step 1, what we're doing is we're sorting all of the tokens that the model chooses in descending order based on probability. So for example, the token the occurs first because it has the highest probability of 15%. And then the token A occurs second because it has the second highest probability of 14%. Notice very quickly, these probabilities and these probabilities are not consistent. That's only because these numbers here are just fake numbers. They're just for demonstration purposes. Once we have sorted these by probability, we want to keep the smallest set of tokens whose total probability is greater than or equal to the threshold. So for example, here we set our threshold P equal to 0.7. And so we select these first 6 tokens, because if we were to add these 6 tokens up here, that would equal to 70%. So it keeps this equality. So essentially though, what we've done is we've reduced it, all of the potential next tokens, to this small list of just 6. From there, the question is, how do we choose which token we use? Well, what we do is we sample proportionally from these 6. What does it mean to sample proportionally? Well, actually, if you look at this, this is 15, 14, 12, 11, 10, and 9. You could think about it like this. Let's get a box and put each of these words in. So we put the word the 15 times, the word a 14 times, the word that 12 times, and so on. We shuffle the box and we randomly take one ticket out, and so that is the word that the model predicts. And this is what we mean by proportionally. The word the will be chosen the most because it is the highest probability, but there is still randomness involved. So we're not necessarily getting the highest probability word each time. So this is one such sampling method. It actually turns out that there's heaps of sampling methods. And in the lab, you're going to be playing around with a few different ones. So we have greedy, 5-beam, contrastive, and random sampling. Now, some of you will actually know how these works because you also do another course that I'm involved in. But if you do know, that's okay. I would rather you maybe pretend you don't know just for this exercise, because there is a very important skill that I want you to develop here. So you could ask me, Thomas, how do these methods work? And I'm going to tell you that I'm not telling you. So why am I doing this? It's not to be annoying. It's one thing that I really want to instill, and I think it's so important, something I'm quite passionate about, is the scientific method. And so the scientific method, you may have not seen this before, but it is something that is implicitly done whenever we're reasoning about things, we're kind of iterating. So you start with some sort of hypothesis, you do an experiment to try to verify your hypothesis, and when you analyze that, you'll then have some more evidence, and that will lead you to revising the hypothesis. Now, why am I telling you about this in an AI literacy course? I think that the scientific method is quite important in how we approach the ever-evolving AI world. So already in this course, early in this course, we told you about prompting and things like that. And Mary Lou was saying a lot of this prompting stuff has already changed a lot since AI models have been around. And it's so very true. AI is continually being released, new methods are being selected, context windows are being increased, innovations like RAG get released. So lots of different things happen. And so I want you to be able to develop a skill of coming up with a hypothesis. What do I think is going on here? Testing that hypothesis and keep refining. I think this is really important because when you leave this course, I want you to be able to, when you interact with new AI, to be able to come up with these ideas yourself, because new things are going to be released. There might be no resources available on how this works. And so it's up to you to experiment. And so that's one thing I just want to bring up. And if you have any questions about this, please do let me know. Why am I mentioning this now? Well, the reason why is I've not told you how these different sampling methods work. I want you to play around with these different sampling methods with different sentences and try to hypothesize what is going on here. I want you to hypothesize which sampling methods create the most useful responses. And then this is going to lead you to maybe start thinking about how do these different samplers work. I think this is a very important skill to develop. On your own device, you're going to be interacting with these different sampling methods. So very quickly, let's talk about what's going to happen during the lab and what I'm about to do in the live demonstration. So we provide you with some prompts. So for example, the prompt I start off with is, I like playing Minecraft because I'm still a child inside. It's a great game. What I want you to do is I want you to change this prompt and then run the code and see what do the different sampling methods select when we continue this sentence. What you're going to do in your groups is you're going to create a table of different prompts. So for example, you can start with the Minecraft one, but then I want you to choose heaps of different prompts in your group and make this table comparing the greedy sampler with the 5-bean sampler, with the contrastive search sampler, with the random sampling. I want you to do this so you can start seeing what are the differences between what is produced from the model for each of these different methods. So I've kind of told you about this. Let's actually demo this code. I'm going to go really quickly to the code. So I'm just going to flick over. So some information here, just some things. I've pretty much verbally said all of this. We've got our prompt here. I like playing Minecraft. I'm actually just going to run this code whilst I'm talking through it because it can take a few moments to run. What you're going to be doing in the lab, as I said, you're going to change this prompt to be whatever you would like it to be, but I want you to keep changing it over and over again. How this GPT-2 model works is it's very good at just continuing sentences, okay? And so that's what's going to be, you're going to be doing here. Write some sentences and see how the model acts. But also feel free to ask it questions. That is also technically a continuation. Here we've got our different methods. You don't have to change any of this code, but you can see what we're doing is we're doing the greedy sampler, and we're also doing different ones, so 5 beans and stuff like that. But here, the output is really what I want you to look at. So for example, we see the greedy output. It says, I like playing Minecraft. That was the sentence that we started with at the beginning, the prompt. Then it inserts a full stop and just keeps repeating, I like playing Minecraft, I like playing Minecraft, I like playing Minecraft, and so on. Okay, so it just kind of goes on this endless loop of liking Minecraft. The 5-bean one is here as well. The contrastive as well. And then the random one, which I think is quite funny. I like playing Minecraft, so I'm going to play that too. I've been playing this game for a while now. I was really into it when I was a kid, and so on. So I want you to, and then it says, when I was 12, I got a job at an animation company. So I was really into it. So you can see they're giving us very, very different answers, very different sentence outputs. And that's what I want you to interact here with. So you can change this prompt to be whatever you want. So for example, what is the temperature today? Oops. It is freezing in Sydney. Okay. You can also play around with this max length. So if I change it to 150, it essentially is changing how much the model can generate. And so if I run this, we will see that it starts outputting some other things. So for example, the greedy one, the temperature is about 1.5 degrees Celsius, 3.5 degrees Fahrenheit, and so on. So, it's just going on all of these different things, which is quite interesting. So play around with these. I would love to see what you guys determine. Hopefully this is nice and fun. We're really interacting with stuff that you would not see when you're interacting with these commercial LLMs. So I really look forward to seeing what you come with this. But please, again, I know that there is always the feeling, let's just jump straight to working out what these samplers are doing by Googling. I really think it's valuable for you to engage in this process, this iterative process of coming up with hypotheses and testing them, looking for patterns for yourselves. It's a very important skill to learn. Okay, let's talk about task 4, fine-tuning. And so the outcome for this is understand the difference between pre-training and fine-tuning. So as we saw in task 1, we talked about how pre-training is the initial stage where the model learns language patterns by predicting the next token across billions of examples. On the other hand, fine-tuning, we start from the pre-trained model and then we continue the exact same training process, but on a much smaller targeted data set. Why do we do this? Well, the model has already learned general language patterns from the literally billions of articles it's already looked at. But often we only need it to see a few relatively small number of examples of something new for it to kind of learn some of these new elements. And so what we do is we select a small number of examples, often just hundreds, to pick up some sort of new style or domain. So when we say pick up a new style, this might refer to how it speaks when it does its outputs. So maybe, for example, you could train it to start talking like a poet. This is not something that it would normally do from its pre-training, but from our fine-tuning, we can try to get it to act like that. And the other thing is we can start to get it to learn a new domain. So during its fine-tuning, it may not have seen, for example, new news articles, or maybe there's a new development in science that the model was never trained on, and so you want to learn about that. Or maybe you're a company and you want the fine-tuned model to only really talk about stuff that's relative to your company. So fine-tuning is where we kind of like, as the name literally suggests, we're making some little tuning to the massive pre-trained model. Why do this? Well, again, this takes minutes rather than months. The pre-training, the main kind of like goal is really for it to learn general language patterns. And this is really takes a lot of time. If you think about what we looked at in task 1, it's quite an intricate, quite an involved process. And so we already have that base. Now we're just making it optimized, or sorry, specialized is the word I meant to use. So not optimized, specialized. So in the labs, we're actually going to do fine-tuning ourselves. So on your device, the first thing you're going to do is to run the 3 fine-tuning examples that I've already done for you. And there's going to be some discussions around that. So, that's fun, but also it's a bit boring. You're just doing the example that I chose. What I think is really cool is you guys are going to get an opportunity to design your own fine-tuning data set and to actually fine-tune the model on that. So in your groups, you're going to decide on how do you want to fine-tune this model, and you're going to come up with some essentially training data, and we're going to fine-tune the model on that data. As part of the evaluation as well, we want to compare how the pre-trained GPT-2 outputs are compared to the fine-tuned model that you produce. So in the live demonstration, there are 3 examples we're going to do. The first one is a recipe data set. So in the recipe data set, it's very much about tuning the model so that it really focuses on recipes. It's becoming specialized in recipes. Another example is where we're going to be replacing full stops with asterisks. So this one's really interesting because in a way, we're actually changing how the model thinks about language patterns. We're kind of saying to it, no, actually, you don't use full stops anymore, you use asterisks. So this is an example of where we're actually changing the output space. The third example is where we want to do this thing called named entity recognition. So this is a classic natural language processing problem. And this is where you have a sentence. So Lucy is friends with Jack, and they often walk to school together. And you want the model to kind of say how many named entities. So the named entities in this sentence are Lucy and Jack, because Lucy and Jack are entities. They're people, but they're also named. They have names. So we want the model to predict two because there's two names here, Lucy and Jack. So let's actually have a look at this. So I'm going to switch back to the code, and we're looking at task 4 here. So there's a lot of different code chunks to run. The first one, I'm going to run it whilst I speak. We've got here heaps of different sentences of recipe texts. So for example, simmer the soup on low heat for 30 minutes, stirring occasionally to prevent sticking. So you've got heaps of different examples here. And what we're doing is we're fine-tuning the model on this data. And you can see we load that data in here. So far, though, all we're doing is we're creating a data set of these sentences. This first chunk does not actually do the fine-tuning. This second one does. So we run this, and this is actually the one I should have run whilst I was speaking, but it's okay. This one takes a bit of time. And actually, this is great. We can look at this very quickly. This is showing us the training loss over time. So this is what's happening as we're doing our fine-tuning. You can see the training loss is actually getting lower. Why is it getting lower? Because the model is starting to do a better job as we do our fine-tuning at understanding the restaurant data. It's starting to talk more about restaurants. It's starting to, sorry, recipes, not restaurants. But you see it's getting better at this specialized task as we go. So that's just the fine-tuning. Let's actually have a look at what happens. So here, very simply, I know there's a lot of complicated code, but what we're doing is we're just going to be changing the prompt. So I've got a prompt here. What is the temperature like today? And what we're doing is we're going to be generating the output using the fine-tuned model, but also the pre-trained model from before. So the pre-trained one, just to be clear, this is GPT-2 as made by OpenAI. The fine-tuned one is where we have used our recipe data. And so when I run this code very quickly, what we will see is we get some different outputs. So the pre-trained model says, what is the temperature like today? A typical day is about 3 degrees Celsius. I mean, that's pretty sad. It's very cold. But anyway, you can see it just has an actual conversation about temperature. The fine-tuned one, what is the temperature like today? How much? What is the temperature? And then it kind of pivots and it starts talking about what it really wants to talk about, which is food. So how much water is there? Will there be water turned into juice? Or is it too cold with a splash? Invent the heat to cool the water to a simmering point, and so on. Cook the chicken. So you can see, even though we asked it about the temperature, this model, it really just wants to talk about recipes because that's what it's been fine-tuned on. So you can see the fine-tuning here has literally shifted the probabilities that the LLM produces to be more, I was going to say the word biased, but I realized that essentially is biased. Like we've shifted it towards recipe data. So that's the first example. Example 2, we have to start by running this chunk to load a new version of GPT-2. And in this text here, I'm just going to run this chunk and then also run this one below it, just so we do the training whilst I'm speaking. We have heaps of examples here. And so, for example, our cats on the mat example from before, notice these are all real sentences, but what I have done is I have changed the full stop with an asterisk. And that's the same for all of these examples. And so now that this model has trained, when I run this code here, again, I'm going to say, what is the temperature like today? Let's run this and compare the pre-trained and fine-tuned model. The pre-trained one, just normal conversations, asking a lot of questions. The fine-tuned one, what is the temperature like today? Question mark, asterisk. It's warm in the morning, asterisk. The house is warm, asterisk. The air is fresh, asterisk. The leaves are greasy, asterisk. You can see that from this fine-tuning, we've literally changed the structure of how the LLM produces its outputs. So now it's kind of learnt a new language pattern, because that's what LLMs really are doing. They're learning language patterns. It's learnt a new language pattern now, where instead of predicting full stops, we predict asterisks. I think this is really cool because a lot of the time you do actually want to change the output nature of things. This is one way that you could do that. Example 3, fine-tuning on named entity counting. So I'm going to run this again, all of these chunks here, just because we don't have as much time and I want to make sure this is running in the background. So let's have a look at this training data, this NER, which stands for named entity recognition. So we've got heaps of examples here. These first examples, these are ones we have 0 named entities. So the cat sat on the mat. There are no names here, so named entities equals 0. This one here, 4 named entities. Alice, Bob, Carol, and David all arrived at the same time. There's 4. And so the goal is that hopefully by seeing lots of these examples, we can get the model to predict how many named entities there are. Why did I add these /n's? The reason why is when I was generating this and I was doing my own testing at home, the model seemed to output how many named entities or try to do it and then just keep rambling on. I was trying to get it to naturally end on its own, but it didn't really work. But that's just more of an aside. Let's actually run this code to see the before and after fine-tuning. So here I say, Tom and Sarah walk to the park. Output, named entities equal. So ideally, this model should just insert one number and ideally a new line character that says how many named entities there are. So we would expect this model to say 2. Let's have a look at what happens. The pre-trained model says that there is 1 named entities. The fine-tuned model says that there are 0. So here, this is kind of an example where we had this really cool idea for fine-tuning, but the model has not really picked up on this. There are some different takeaways here that I would encourage you to have a read later. I think one of the reasons why this doesn't work here is, as it says, GPT-2 was not designed for this kind of structured reasoning. Okay. Also, keep in mind, I think for this task, our fine-tuning is quite a small data set. And how this kind of stuff would probably work in real life is you would train a BERT model, for example, specifically with the task of doing this named entity task. But I'm sure this actually would work. Well, actually, I'm not sure. I should not say sure. I have high confidence that this would work if you use like one of the newer GPT-5 models or something like that. But don't forget, this is GPT-2. So it's literally a smaller model as well. Why did I include this example if it didn't work? I think, firstly, it's a really cool example, but I really want you to kind of see like what the limits are here. So what you're going to do on your own is I want you in your labs to come up with your own data set. So together, I want you to discuss something in common. So you can choose a topic, a style, or a pattern. So for example, a topic would be recipes. A pattern would be the full stop asterisk substitution. Then come up with some sentences as a group and try to train this model and fine-tune this model and see how does this change the outputs. So what you can do here is there is this thing in Python, it's called a list. Essentially, it's just a collection of sentences. So what you can do is you just change this here to be my first sentence and then so on. So you can keep adding new sentences as well, another sentence. You're going to build up this together in your group and then run this code. The code itself is pretty much identical to the examples that you saw previously, except now you're writing your own data. So hopefully this is exciting. I really look forward to seeing what different groups produce. I think this is a really awesome job. And maybe if you guys produce something really cool, that could be one of the examples that we show them next semester in the lab. Okay, so I'm just going to head back to the slides very quickly. We're almost over. Task 5 is talking about ethical considerations. It's really important just in general to think about the ethical concerns related to LLMs. In general, there's a lot of ethical considerations around it. In today's lab, or in the lecture and on the lab on Friday, we really want you to focus on some ethical considerations that are in particular prevalent to training. So there are more. These are just 4 examples. And so these are considering the environmental impact of training and prompting LLMs, exploited labor to create filters for prompts, training data, and generated output, copyright material being used as training data, and also fine-tuning and toxicity. So I'm not going to go into these case studies now, but what you're going to do in your group is you're going to review these case studies. And very quickly, I'm again just going to change screens to show you the lab. So if I go all the way to task 5, what you can see is we have here 4 different case studies. In your group, you're going to choose one case study. So for example, we can choose environmental impact. There is there's an article for each one. So I've written a summary, but feel free to click on the link to actually read the paper for yourself. And there's also short videos. We're not going to get you to watch the videos in the lab. In fact, we're going to ask you not to because it's going to get very loud and distracting. But I would very much recommend, because these videos are quite interesting. I mean, I chose them. I looked at each of them and I think they're quite good. I would recommend look at each of the videos before you come to the lab, and that will help you decide which one you want to do. The only one that doesn't have a video for is a fine-tuning for toxicity, mostly because all the videos were incredibly long. But there is an extra research article here as well. Great. So there are some different questions I'm going to get you to discuss. We're about to wrap out because we're about to finish. I hope you enjoyed this lab. I had a lot of fun making it. AI disclaimer, I used AI extensively to make this presentation and lab content. I'm actually making a resource explaining how I use AI because I think this is also another good example of how you can use AI to produce things like this. But I've run out of time. So I want to put an AI disclaimer in there because I want to not be a hypocrite because we asked you to do it. And my AI disclaimer is I use lots of AI. I've not told you how I've used it, but I will be telling you soon. I've got an article I'm going to write about that. Anyway, that's the end of the lecture. I hope you guys all I hope you're looking forward to it, and it's good to see you all back here in class. Thank you.